Thank you very much. So I'll start off by saying I agree with everything that's been said before me. So just repeat it. I think the piece, if you were here for the earlier session, that I'm going to focus on today is some success stories that focus on addressing a problem that was called out by a number of the speakers at the utility side, which is the success or failure of many smart grid programs have really come down to the quality or availability of networking and communications out in the field, and that's what we focus on. So we'll try to share a few success stories from around the world. So I'm going to get right into operational success stories and just make a few points that on some of the projects that actually others have mentioned before us. There are programs like Pacific Gas and Electric in North America that cover 70,000 square miles of service territory connecting millions of devices that operate at 99.99% data reliability. You can build real-time networks that communicate out to the edge of the network. These programs will, from an operational perspective, engage the consumer, and this have been a number of questions around consumer engagement. One of the things that you get as a real economic and customer benefit is remote disconnect. That may sound surprising. Who wants to be disconnected from the power grid? But what we find is that when you implement remote disconnect, that also means you can implement remote connect of power in real time. If someone is in arrears, they pay their bill, they can be immediately turned back on as they're standing in front of the operator. A number of programs have been mentioned around storm recovery and disaster recovery, including Superstorm Sandy, at Baltimore Gas and Electric and Pepco, two clients of ours on the East Coast. Numbers included here, but with the implementation of smart grid communications and smart metering, the utilities dramatically decreased their restoration time after a storm event. And you can contrast this to the utilities in New York and the commissions Laurent mentioned, where they didn't have communications and they didn't have networking, and they were hauled in front of government to answer. You will get operational savings and customer improvement from having real-time connectivity to check the service status at a home. We have utilities now who have built this into the mobile app where the customer, if they think they have lost power, can push a button on their mobile phone and instantly check the power status of their own home over the network, avoiding, for one utility that we work with, 40,000 truck rolls in a month. We know that revenue assurance and losses are a big issue here in India, as they are in Brazil, where we do quite a bit of work. Suffice it to say that the advanced analytics that come from high data rate sampling off of smart meters can be a huge enhancement to this effort. Tamper switches are not the answer to theft detection here or in Brazil or in the United States. They're nice, they don't make the difference. High data rate sampling of 1-minute data where you can pinpoint losses and characterize load usage is possible with the smart meters that you will deploy. You will then extend that into, without adding additional equipment, using the data from smart metering and related systems into transformer load management. You can, the point was made about GIS data, and I totally agree. If you have good GIS data, which will come as a byproduct if you pay attention during your smart meter deployments, you will be able to use that GIS data and the smart metering data to do virtualized transformer monitoring and load planning. I know a lot of the examples have been given and the question was asked, how do we make this appropriate for India and not just for Europe or for the US? I would call an example of CPFL in Brazil. CPFL in Brazil from a consumption pattern, from a loss profiling perspective, would be very similar. Sao Paulo, Brazil, very similar to many of the major cities here in India, and they have demonstrated at great success the deployment of smart metering for their large customers and now deploying, despite frankly very poor economic conditions in Brazil, mass deployment across the residential base. And then in Australia, just to show that this isn't something where the laws of physics are different in one part of the world than the next. It's City Power Power Core, the mobile app, ties into the outage and restoration service so customers see that. My favorite part is the CEO, the MD of the company, has his own version where he tracks the outages and can push the button which is tied to their work order management system and call the workman on his mobile anytime he wants. And as he points out, you only have to do that once or twice before everybody starts to work a little bit harder. And then through distribution automation, I agree entirely with Mr. Gupta this morning from CESC. The integration of distribution automation and AMI is critical. You can get the kinds of performance using the standards that were mentioned, IEC 61850 or DMP3, with latency between devices of less than 10 milliseconds over the same network that you would deploy with AMI. Off the shelf, there's no custom development required. It's available and deployed at mass volume today. And that extends into automated schemes for self-healing grids, which are being deployed again in quantities of tens of thousands of teaming schemes deployed around the world. Energy conservation is important. One topic I have not heard talked much about here at the conference is the importance of conservation voltage reduction or volt-var optimization as a scheme to get demand response even on an emergency basis without having to engage the consumer. With automation that you will deploy, you can turn the dials up or down in terms of the voltage on the grid, which is often over-provisioned, not under-provisioned, as a means of avoiding some of the rolling brownouts as an alternative to energy conservation. Averagely, we see somewhere between 2 and 3% total energy efficiency. Some utilities like Dominion in the US have seen as much as 7, but when you look at that on an incidental basis, it can be into the mid-teens. And then finally, to the question of consumer engagement, I would disagree with the characterization earlier that consumers in the places like the US don't care because it's not enough money. We see great consumer engagement. When you give people the information, there is a huge segment of the population. What we find is typically between 25 and 35% in the US and a little bit more in developing countries who will do just about anything to lower their energy bill. So if you put the appropriate price signal out there, the market, whether you as the utility provide the device or it's a bring your own device to the program, will follow. And you can do that through pricing programs as well. I believe my last, second to last slide here as an example is around renewables. I absolutely agree with the characterizations that renewable integration at scale is not as easy as people seem to think it is. There are, in Hawaii, where we are doing a project with Hawaiian Electric, they have a goal of 100% carbon-free electricity. What they've, at 20% penetration of rooftop solar, they've had to stop grid interconnects until the technology, the automation technology can be put out because it creates too much voltage instability and too many safety issues on the grid. Which then, I've been very pleased to see the connection between smart grids and smart cities highlighted. Examples from around the world, the city of Copenhagen, the city of Paris, utilities like Florida Power and Light, who have 4.5 million electricity meters deployed on a common network, adding 500,000 streetlights for energy efficiency and improved operations. So nobody talks about money at these things. It's impolite. I will talk about money. One thing we hear from a value perspective that's been mentioned many times is that the value proposition of advanced metering as a revenue cycle service is generally a pretty poor business case. It's a poor business case in North America. It's a poor business case in Europe. It will be a poor business case in India. The key to unlocking the full value of smart grid is to do more than advanced metering, to use the advanced meter as a sensor on the end of the network, to deploy a networking infrastructure that will then extend into distribution automation, energy efficiency, ultimately renewable integration at scale. And what we find is if you do it correctly, the multiplier effect that comes from doing multiple applications simultaneously improves the overall business case and the value creation dramatically. That's an important lesson to be learned when you're contemplating what's the difference between cheap and what's the difference between good value. So the other thing that nobody talks about in the PowerPoint slides is, isn't everything great? Because the PowerPoints all looked terrific. And the fact is, when we look around the world, there are a number of failures. And so a cautionary tale that goes out is there are a number of failure modes that have happened around smart meters and smart grids more broadly, and we have to keep our eye open. One failure is the one that people think of is failure to launch, that the technology was deployed and it never really worked, or it didn't work to meet our specs. And that's certainly been a problem. But the more common and frankly the more subversive failure modes that happen are failure to deliver and failure to sustain. Failure to deliver is that the technology is deployed and it kind of works and it generally doesn't keel over on a daily basis, but it was never able to deliver the business value that was the motivation for the program. And failure to sustain is that it does that only in a means that has more cost than was originally anticipated, and so that the maintenance and the overall expense of the system never is outweighed by the benefits it creates. And our part of the business has to take credit for this because frankly, communications and networking have too often been that cause of failure. And you heard that this morning from Tata and from CESC and others that have real live experience in the field, that the absence of good, reliable, high-speed communications to the field is often the root of the problem. So a quick set of suggestions as we move on and wrap up. When you graduated from school, it became okay to steal everybody else's ideas. I encourage you to do so. If you're not able to get on a plane and fly around the world, let the world experiences come to you. Leverage the parties here up on the dais, and they will tell you. I would tell you also that you will do more than you think you will. The programs are hard and the technologies are complex, so people tend to want to narrow the focus to do the least possible things to meet the requirements of the moment. Fight the urge to think that way. Think more broadly because you will do more over time. It has been delightful to hear standards and interoperability. Please, other than the metering standards which have been developed and adopted, which are quite good, you do not need to invent any new standards in India. I will repeat, there is no need to invent any new standards in India. Please see bullet point 1. Steal all of the standards that already exist. And then again, remember, differentiate cost from value. Thank you very much.